Hello everyone, this is lecture 21, Lebnitz theorem part 2. So here we take one more example. Y is equal to sine m sine inverse x. Then we have to show that equation. So here we use the Leibniz theorem. We have given y is equal to sine m sine inverse x. So first you differentiating, suppose this is equation 1. So the equation 1, both side with respect to x. So we get y1, that is a derivative of that y, and the differentiation of that term is what? Derivative of sine is what? Cos m sine inverse x. And now derivative of m sine inverse x, we write m upon under root 1 minus x square. So here this you can write y1 m root 1 minus x square into cos m sine inverse x. So multiply that term on the left hand side. We can write root 1 minus x square into y1, and this you write m, that one, cos m sine inverse x. Now squaring both sides, so we get 1 minus x square y1 square is equal to m square cos square m sine inverse x. Now cos square m sine inverse x, so you know the formula, cos square plus sine square theta, we get 1. So we can write m square 1 minus sine square m sine inverse x. Now this become what? This is y. So we write m square 1 minus y square. So the equation become what? 1 minus x square y1 square m square 1 minus y square. Now again differentiating that term because we required yn plus 2. So here we have only y1. So again differentiating, suppose says equation 2 both sides. So we get what? 1 minus x square, first function same, and the derivative of y1 square is what? 2 y1 y2. Now minus the second function, we say same, that is y1, and the derivative of that function is what? Is 2x with a negative sign, we write outside here. Now this is y1 square is equal to, take the derivative on the left hand side, we write m square, and the derivative of that one, derivative of 1 is 0, and minus y square, we write minus 2y into y1. So on simplify we can write 1 minus x square y2 minus x y1 plus m square y is equal to 0. We just cancel the y1 in the whole equation, and also 2 and 2. So we get that equation. Says this is suppose equation number 3rd. Now we just take differentiation, or differentiating n time by Leibniz theorem. So So how we differentiate? We just apply the nth derivative on that equation. So we write the nth derivative, we write Tn of 1 minus x square y2 n time derivative of x y1 plus n time derivative of m square y. So on expanding this, you just apply the Leibniz theorem here. The first function 1 minus x square into y. So you take y2 as a u and 1 minus x square is v, and for the similar for in that second term. So for first term, when we expand, we get 1 minus x square first function same, and the nth derivative of y2, we get y n plus 2 plus the second term nc1. So nc1 is n, one time derivative of that 1 minus x square is minus 2x, and n minus one time derivative of y2. So n minus one time derivative of y2 is what? We write y n plus 1, and the third term becomes 0 because only the third term is also obtained here. What is that? nc2. So we write n minus 1 upon factorial 2, and the n minus 2 time derivative of y2. So we write that is become yn, and 2 time derivative of that function is minus 2. So this is the expansion of the first term when we apply the Leibniz theorem, and similarly on the second term we write minus x y n plus 1 plus n 1 yn, this become, and on that term when we apply the nth derivative, we just write m square yn is equal to 0. Now you just simplify that equation. So first you write the highest derivative, that is yn plus 2. This is the only term. Now take yn plus 1 as a common, so you get yn plus 1. So you write this one, this become minus 2 nx and minus x, and similarly you just take common the yn. When you take the yn, so yn is there, that 2 is cancelled, so we get minus n square minus n from that term, and here we get minus n and plus m square y, and we write yn is equal to 0. On simplify, we prove 1 minus x square yn plus 2, and that can be written like minus 2 n plus 1 x y n plus 1, and the term become right written m square minus n square, sorry, that n should be positive here, so we get y n is equal to 0. So we can say hence proved. So in that way you can use the Leibniz theorem. When we use the Leibniz theorem, you have to remember, if we have to find the nth derivative of product of two functions, so we apply Leibniz theorem. So take one more example, y is equal to a cos log x b sin log x. Then we have to show that the equation 1 and equation 2. First we prove the equation 1, then we prove the second equation. So here, as in previous example we discussed, we take the given function a cos log x plus b sin log x. So first you differentiation of that equation 1 with respect to x both side. So we write y1 become minus a sin log x, the derivative of that, into the log x, derivative of log x 1 upon x, plus derivative of that term b cos log x into 1 upon x. Now that x next take on the right hand side, so we write y x y1 minus a sine log x plus b cos log x. Now again differentiating equations is 2, we say this is equation 2 with respect to x. So when we take the derivative, second derivative of that equation, so we write x, the derivative of y1 is what? Become y2 plus the derivative of x is 1, so we write y1 first and second function, and on that we write minus a, the derivative of sine is cos log x and 1 upon x minus b sine log x into 1 upon x. Now take x as a common or a negative sign, so we write and take on the right hand side, so we write x y2 plus y1 minus a cos log x plus b sine log x. So here you see this become what? This is y. From equation 1 we can write this is minus y, and on simplification of right left hand side we write x square y2 x y1, or take that minus y on the left hand side, so we write x square y2 x y1 plus y is equal to 0. Now this is the first proof. Now we have to prove the second equation, and here you see if we take the nth derivative of that equation, so we get yn plus 2. N plus 2 is what? The nth derivative of y. So we apply here, this is the equation 3, take the nth derivative of that equation 3. Now take the nth derivative, so differentiate equation 3 n time by using Lebnitz theorem. So take the nth derivative, and what is the nth derivative? We write n time derivative of x square y2 n time derivative of x y1 and n time derivative of y is equal to 0. So here apply the Leibniz theorem. So you take y2 as a first function, or say u, and x square as a second function, say v. So expand it, so we write nc0 is 1, so we write x square, n time derivative of y2 it become y n plus 2, means n plus 2 time derivative, plus the n c1, the n minus 1 time derivative of y2 it become y n plus 1, and 1 time derivative of x square is 2x plus n minus 1 by factorial 2 yn into 2 plus, now take the second term, it will be written as x yn plus 1 plus nc1, we get n yn and 1 time derivative of x 1, so and the last term you just write yn, the n time derivative of y it become yn. Now simplify that, so we can write what? X square yn plus 2 2nx yn plus 1 plus n minus 1 factorial 2, that 2 is also cancelled, so there's no need to write, you write yn plus n yn plus 1 plus n yn plus yn is equal to 0. Now just arrange the terms. You can write x square yn plus 2. Now take yn plus 1 as a common, yn plus 1. So you write 2nx and yn plus 1 is there. So write plus n and take yn as a common. So we write from that term, we write n square minus n, and this become plus n and sorry that one and plus 1. So from that this will be cancelled and we get take 2n as a common, n as a common, so write n 2x plus 1 yn plus 1 and this n square plus 1 yn is equal to 0. So this is the required result. So in this way you can use the Lebnitz theorem. Thank you, and the further topic we discuss in the next lectures.